So picture this. It's 2008, the middle of a massive global financial crisis, and this 9-page paper just appears online. It's written by a mysterious figure named Satoshi Nakamoto, and what it proposed was, well, pretty radical. Today we're going to break down that exact paper, the one that started it all.
Right from the start, the paper asks this really simple but huge question. I mean, think about it. When you give someone a $10 bill, that's it. The deal is done. It's instant, it's final, and nobody else is involved. So why, the paper asks, can't our digital money work just like that?
And that's the core idea, right there. It's all about cutting out the middleman. Every single time you buy a coffee or order something online, you're trusting a bank or a credit card company to handle that transaction. Nakamoto was imagining a world where you just don't have to.
And here's the magic trick. Instead of relying on trusting a big company, this whole system would be built on something else entirely. Something you can verify for yourself. Pure mathematics. Cryptographic proof. So, how on earth do you actually build something like that?
Well, to really get how brilliant the solution is, we first have to wrap our heads around the very specific problem the white paper was trying to solve, because it's actually a bit deeper than just sending money online.
Nakamoto just lays it right out there. Look, the problem isn't that our current system is totally broken. The problem is that the trust we place in it, well, it has weaknesses. It has real costs built right into the system.
And this comparison really makes it click. Physical cash is just so simple. It's yours, you hand it to me, now it's mine. End of story. Online payments, though, they're reversible. And because they're reversible, you need people to mediate disputes, which adds costs, and it puts merchants at risk of fraud. It's complicated. Okay, so with the problem laid out, Nakamoto starts building the solution. And the very first step? We have to completely redefine what a digital coin even is.
This is such a cool shift in thinking. A coin isn't some file you have. It's a story. It's a verified history of ownership, all linked together. A hash here is just a unique digital fingerprint of the transaction. So you can prove you own the coin because you can follow this unbroken chain of signatures all the way back.
So here's how that works in practice. Each owner uses their secret private key to digitally sign the coin over to the next person's public key. You can think of it like this. Your public key is your bank account number. Anyone can see it and send you money, but your private key, that's your PIN. Only you have it, and you use it to approve any money going out. It's brilliant because anyone can check the signatures to make sure the chain is legit.
All right, so we've got a public chain of ownership. That's a huge first step, but it still doesn't solve the absolute biggest problem for any kind of digital cash.
Exactly. This is the whole ballgame, the double spending problem. If I have a digital coin, what's to stop me from sending it to you and then sending that exact same coin to someone else? With digital stuff, copying is easy. So how do you make sure a digital coin can only be spent once?
And that's the real challenge, isn't it? We need one single public ledger, a definitive history of every transaction in the right order that everyone agrees on. But, and this is the kicker, we have to do it without a boss. No bank, no central server, nobody in charge to say what's true.
Okay, and this is the heart of the entire paper. This is the absolutely elegant solution to creating that shared history without a central leader. It's a concept called proof of work. The idea kicks off with something like a public timestamp server. Basically, you take a bunch of recent transactions, you create that unique digital fingerprint, the hash, and you broadcast it. That proves all those transactions existed at that moment. Then you take that hash and include it in the next one, creating a chain.
But, where do you publish this stuff? The paper jokes you can't just put it in a newspaper every day. So the network needs its own way of making this public and permanent. And that way turns out to be this really clever computational puzzle.
Think of proof of work like a lottery, but instead of buying tickets with money, you buy them with computing power. All the computers or nodes on the network are racing to solve a really hard math problem. The first one to find the answer gets to add the next block of transactions to the chain. So the majority vote isn't based on who you are, it's based on how much computing power you have. One CPU, one vote.
And this is what makes the whole thing so secure. If you wanted to go back and change an old transaction, you'd have to solve the puzzle for that block and for every single block that's been added on top of it since. And you'd have to do it all faster than the rest of the network, which is still racing ahead adding new blocks. It's basically impossible.
And the security just stacks up incredibly fast. The paper actually does the math. It says if an attacker somehow controlled 10% of the network's power, once a transaction is buried under just 5 new blocks, their chance of ever being able to change it drops to less than 0.1%. The security just keeps growing exponentially.
So we've got the big ideas down, the chain of signatures for ownership and proof of work to stop any cheating. Now, let's look at how this all actually works together on the network, step by step.
It's this constant cycle happening all the time. You send a transaction, it gets broadcast to everyone. All the nodes gather it up with other recent transactions. Then the race begins to solve the puzzle for that block. When someone wins, they show everyone their work. And if it checks out, that block gets added to the chain. And the whole process starts over again for the next one.
But you might be wondering, why would anyone bother doing all this work? Well, there's a pretty big incentive. The node that solves the puzzle and adds the new block gets a reward of brand new coins. Plus, they get to keep any small transaction fees people include. This is what encourages people to participate, and it's also how new money gets introduced into the system.
So, after walking us through the problem, the building blocks, and the mechanics, the paper brings it all home with this really powerful conclusion.
And that's it. That one sentence sums up the entire breakthrough. By weaving together digital signatures, a peer-to-peer network, and this proof-of-work puzzle, Nakamoto laid out a blueprint for a system where you don't need to trust anyone to transact. You just need to trust the math.
The paper itself doesn't really try to answer this. It just leaves us with this massive, open-ended question. It gives us the technical blueprint for a completely new way of thinking about value and exchange. And what we build with that blueprint? Well, that's a story that we're all still figuring out today.